All right, today I want to talk about El Nino and ocean circulation. So how do things circulate based on El Nino? Okay, so that's the topic for today. So let's have at it. Hey, what is El Nino? It's a climate pattern that occurs across the tropical Pacific Ocean on average every 5 years, but over a period varies from 3 to 7 years, and it's very significant. Okay, best known for its association with floods and droughts and other weather disturbances in many regions of the world, which vary with each event. Developing countries are dependent upon agriculture and fishing, particularly those bordering the Pacific Ocean, are the most affected. That really means Australia and Peru and such. This is one of the important effects of El Nino. This is an interesting graph of the anchovy catch in Peru and Ecuador, and each of the little triangles here, you can kind of see the frequency. It's not exactly equivalent. Whenever there is an El Nino year, they typically will have a lower catch of fish. I think you do see this huge bump here. My guess is there was a high demand for the fish, and they might have overfished. And then they overfished, and then all of a sudden, for many years, they didn't have fish to catch because the fish had all died out. So there's an important effect to that. Now, what's going on here? Well, turns out there is an upwelling off the coast of Peru and Chile. This upwelling pushes cold, nutrient-rich water up to the surface, and that allows the fish and all the living organisms to have a very nutrient-rich area. So you have this upwelling. It's caused by the Ekman transport, which we learned about in a previous podcast. All right, and so this is very important for the world. So that's just what's normally happening. The normal conditions are such. Basically, what you've got is normally, if whatever you want to call it normal, we'll talk about why there's sort of not normal. Normally what you've got is you've got cold water off the coast of Peru over here. All right, and you've got these strong equatorial currents, means currents at the equator, that are traveling from the west to the west, from the west coast of the United States towards this direction. That creates, if you've got warm water traveling, you're going to have warm, wet conditions. These will be hot, humid places. And I know not all of Australia is hot and humid, but particularly kind of in this region right here, hot and humid. This is Indonesia, which is a very hot and humid place to live. However, during El Nino, what happens is the temperature of the water warms up in the ocean. When it warms up in the ocean, it actually reverses the current, and the current now shifts in the other direction, back towards the east. And now what you have is you have warm water off the coast of Peru. Now, since this is warm, wet water, then we're going to get a lot more water, as in lots of more rainstorms that are going to take place here. Australia, on the other hand, is going to become dry. This will be a drought over here. And you can get droughts, and it happens, all kinds of issues occur here, and it's related to the temperature, the sea surface temperature of the ocean. This is caused by what's called the Walker circulation. The Walker circulation, you can see it pictured right here. Basically, a Walker circulation is a convection cell of air above the Earth, and so it creates a convection cell. It heats up here, and then it makes a convection cell that looks like that. And that's the air, and that changes the heat. This is the normal pattern, you know, where this is Australia down here and Peru down here, and so you get the currents that move in this direction. But sometimes the Walker cell gets reversed. Okay, so if it gets reversed and goes in the other direction, that's when you have an El Nino. All right, this creates what's called a convection loop. I think I've already said the Walker cell. You can see this. It goes like this and like that. And this is the normal flow of the water across the ocean, where this is Australia over here and Indonesia, and this is Peru and Chile over here. Okay? Well, let's just kind of get our minds around El Nino. There's a very good little clip that we're going to watch that will help us to understand this.
The notion that a drought in Indonesia or the Philippines could be caused by the same conditions that produce torrential rains in the United States, Peru, and Chile might appear to the casual observer to defy logic. But in fact, that's exactly what can happen during the extraordinary chain of events known as El Nino.
El Nino is the appearance from time to time of warm water in the central and eastern Pacific Ocean. Normally there's a pool of warm water in the western Pacific, and that's because of the way the earth turns and the winds blow. Water piles up in the western part of the basin. The sea level along Indonesia and the Philippines is higher by 60, 50 centimeters than it is off the coast of Peru. So what happens is the winds keep blowing, the water piles up, it heats up in the western part of the Pacific. But then once in a while, it could be every 2 years apart, could be 10 years apart, that wind weakens, and that warm water that's piled up sloshes back towards the central and eastern Pacific. Where the warm water is where you get your evaporative processes, evaporation, and clouds that produce rainfall.
Now that has an effect locally, as you can imagine. Ordinarily, with all those rain clouds over Indonesia, there's a lot of rain in that region. There's rain over Australia. It's fairly dry in the east. During an El Nino, when you've got all this convective precipitation over the east, it can rain a lot in that region. You can have flooding in Peru. Conversely, you have drought over Indonesia and Australia. It can also have effects pretty far away, and the reason that happens is the atmosphere can support these wave-like motions. It's just like dropping a pebble in a stream. Although the pebble is at one little place, the ripples can go very far away. So those ripples can extend, say, over North America and change how the weather patterns over North America are.
How much of what you're telling us today about El Nino being renewed?
In recent years, El Nino events have become the focus of intense scrutiny and discussion, not only among scientists, but within the ranks of the media and the general public as well. In fact, however, the conditions that give rise to these events have been observed for well over a century.
El Nino was named by the Peruvians, actually the first time we've been able to find it in print, looking through Peruvian newspapers, etc., has been 1891. 1892, 1894, 1895. It's the 1890s, early 1890s when it took hold. And it is because during the Christmas season, that winter, December, January, February, the winds would become weaker, just seasonally weaker. And as a result, fish would disappear. The fishermen would fix their boats and their nets and that kind of, they would lay off of fishing. And because it came around Christmas time, they called it El Nino with a capital E and a capital N, which means the Christ child.
The original term El Nino was a much more limited term that had to do with the flow along the coast of Peru and Chile along South America. Now we know that this is not just a local event, it's a much larger scale event. It certainly encompasses the whole equatorial Pacific, maybe has some ramifications in the Indian and Atlantic Ocean as well.
Although scientists understand a great deal more about El Nino events than they once did, there are still many unanswered questions. One of the most basic concerns the precise mechanism that triggers an El Nino.
It appears to begin as an atmospheric event, which quickly transforms into an oceanic event as the water masses in the equatorial Pacific redistribute themselves in response to changes in the wind. This redistribution of mass results in flows, which is what we call currents. But the redistribution of mass associated with that is also a redistribution of heat. And as the heat is moved around, this then feeds back into the atmosphere and over quite long distances.
Cool. All right. Hope that helps you understand how this all works. What causes El Nino? Well, it turns out what causes El Nino is a bit of a scientific debate. You see, there is two things happening. There is a change in the atmospheric circulation. So instead of the circulation going like that, this is in the air, it reverses and it essentially goes like that. Yeah, which then changes the temperature of the ocean. So the question is it the change in the atmospheric circulation that causes the change in the temperature of the ocean, or is it the change in the temperature of the ocean that changes the change in the atmospheric circulation? Most are starting to believe that it's more the temperature change of the ocean, but they're both happening at the same time. So that's kind of an interesting thing. All right. Another view on this whole El Nino kind of phenomenon is instead of thinking of the ocean, or of the southern equatorial ocean, as there's the normal and then there's the El Nino. They think it's either one or the other. It basically exists in two different states, or can exist. So one year you're going to get a normal, whatever that means, situation, and another year you'll get an El Nino. Turns out right now, 2009, 2010, it is an El Nino year. So, and it changes from year to year, but it can cause devastation around the world, which we'll see, I think, in the next podcast. All right, and you can actually see here is a graph of the sea surface temperature data during El Nino years. You can see these are higher temperatures. This right here is degrees Celsius above what they call normal. So in the whatever this year was, 80 something, that was a pretty high El Nino year. And then this I think it was 1998 right here. This was another high El Nino. And we have some weak El Nino years. This year that we're at in 2009, 2010 is actually a weak El Nino year. There's actually one called the La Nina year where you have actually lower temperatures, and we're not going to talk about that, but that's another interesting atmospheric and weather phenomenon. So that's the end of the podcast. I hope you have been learning great things. Have a good day. Hey, my name is Holmes, right? Holmes the Turtle. We'll talk to you later. Bye.